Okay, today we're going to talk about the triangle similarity shortcut. So in class you talked about similar polygons, and just a reminder of that definition. Two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. A quick reminder, proportional means that their ratios are equal. So, oh, and by the way, you're going to want to pause and write everything down. Like when I show you an example or you get a definition, take a second, pause it, and write it all down. You've got to have all of this stuff written down to receive credit on your homework. So proportional means that their ratios are equal. So for example, if I've got two ratios, say 4/3 and I don't know, 12/9, are those proportional? Well, there's a couple ways you can tell. In other words, are those equal? Um, the way that you can tell is you can start, one way is you can reduce the fraction. So 4/3 is already reduced. 12/9 reduces to 4/3. So those are clearly equal. So they're proportional. Another way to tell is if you convert them to their decimal. 4/3 is 1.333 repeating, and 12/9 is also 1.3 repeating. That's another way that you can check that they're proportional. And the last way is you could check their cross products, right? 4 times 9 is 36. 12 times 3 is 36. Their cross products would also be equal. That's another way to tell proportionality. So just a reminder there. Now, for triangles, we don't have to show all their angles, all three angles congruent, and all three sides proportional. There are shortcuts, just like for congruency we had shortcuts, okay? The first one is that two angles have to be congruent. So if we look at this example, triangle ABC and triangle DEF, they have two angles congruent, and those are going to be proportional. They are the same shape, but not the same. I'm sorry, they're going to be similar. They're the same shape, but not the same size. They have two angles that are congruent. Angle C is congruent. Oops, I should use that angle. Is congruent to angle D because they're both 30 degrees. Angle A is congruent to angle E because they both have the same measure. And really, you are supposed to show the third sides are congruent. We don't need to because we know once two angles are congruent, the third angle will always be congruent. So I know angle B must be congruent to angle F because of triangle sum and the third angle property, right? If two angles in a triangle are the same, I know this one has to be 90 by triangle sum. This one also has to be 90. So when you show angle, you're really showing all three angles are congruent. It's just that we don't need to show the third one. It's obvious through triangle sum on each triangle. All right, so that's our angle shortcut. So if we look at this guy, the question is, are the two triangles similar? The answer would be yes, because angle A is congruent to angle J. They're both 65. Angle C is congruent to angle K. They're both 45, and that's enough information to say triangle ABC is similar to triangle. Now we got to get the order right. Angle A was 65 degrees, so I've got to put the 65 angle first. Angle B was the unknown unmarked angle, so that's what L is. And then we have K lastly by angle. So that's what we would say here. The two triangles are similar because of angle. The second shortcut would be called side. This is going to be if the sides are in proportion, remember, not congruent, because clearly these are not the same size, these triangles. So the sides are not going to be congruent, but they have to be in proportion. So we have to check. We have to make the ratios for all three sides. So if I make those ratios, they're clearly all in proportion because they're the same fraction already. But if I reduce them, because that's what we're supposed to do, they come out the same. Or if I converted them to their decimals, they all come out to be the same. So they are in proportion. So therefore, we can say that triangle BHS is is similar to triangle PRQ by side. Again, not because their sides are all congruent, but because they are in proportion. So let's try that one again. Are these two triangles similar? And why? So this one's a little different because the sides aren't all the same. So one tip when you're using side, side, side is you want to look in the triangles and kind of label each side. That's the smallest side in this triangle. This is the medium side in that triangle, and 10 is the largest side in that triangle. Over here, 12 is the smallest side, 16 is the middle side, and then 20 is the largest side. So when we're making our ratios, that's how we're going to make them. We're going to compare the small to the small. So the small side from triangle ABC is 6, and from the other triangle, the small side is 12. That's one ratio. Then I make the medium ratio. So this is my ratio of small sides. The medium size ratio would be 8 over 16. And then the large ratio would be 10 over 20. Another thing to note is whichever triangle you decide to put on top of your ratios, that's always, you always have to use the side from that triangle on the top for the rest of them. In other words, I did 6 over 12. I could have done 12 over 6, but once I set it that I do 6 over 12, the small one over the larger one, I have to do that in each ratio. If I do 6 over 12, I can't do now 16 over 8. I have to do 8 over 16. If I reduce all of these, I get 1/2. That means that they are proportional. That means that triangle ABC is similar to triangle, and once again, I have to do the right order. So I say angle A is opposite the small side. So over here, that's going to be angle F that's opposite the smallest side. Angle B is opposite the largest side. So over here, angle D is opposite the largest side. And that's how I'm going to find the order to get it right. So I've got triangle ABC is similar to triangle FDE, and that's by side, side, side. The sides are all in proportion, remember, they are not congruent. The last shortcut is side angle side. In this one, we need to know two sides are in proportion and then the included angle between them are congruent. So I erased the third side here for a second because if I know that side AB and side DE are in proportion, so 4, the ratio 4 over 2, if they're in proportion with the other side's 10 over 5, which they are because they're both 2 when I reduce them, or 2 over 1, the sides are in proportion. So I've got one side in proportion, the other side in proportion. So two sides proportional. That makes our side and our side. Now remember, in side angle side, it's got to be the angle in between those two sides. So here's angle 85 degrees. They have to be congruent. So I've got enough information to know that these two triangles are similar so that when I connect or draw that third side there, they have to be in proportion. There's no other way I can draw them if those two sides are already in proportion and that angle is the same amount of rotation, the same amount of opening, then those third sides have to also hold that same ratio. Okay, so that would be your third shortcut. It's called side angle side. And remember, the sides do not have to be congruent. It's just that they have to be in proportion. So I could say that triangle ABC is similar to triangle DEF. I don't like my similar symbol there. And that is by side angle side. So those are your three shortcuts. There was one last thing I wanted to talk about. If you think of congruency, there were other shortcuts like angle side angle and angle angle side. Those also work for similarity, but we never discussed them because once you use angle side angle, you already have two angles. You don't even have to worry about the other side, right? I already know two angles are congruent. I don't care about the third side because that's enough information to show that those two triangles would be similar because they already have angle angle, right? We already proved angle angle, so I don't need to check those. So these are the only similarity shortcuts for triangles. Thank you.